Orthomyxovirus. Orthomyxovirus are spherical or filamentous enveloped viruses with a single standard and segmented RNA genome. They have their ability to observe into the mucoprotein receptors on erythrocyte, causing heme agglutinations. These viruses belong to the family Orthomyxoviridae. The virus causes influenza and acute respiratory illnesses. The term myxoviruses was originally proposed for those viruses which are able to attach to the glycoprotein cell surface receptors with the affinity for mucin. These viruses are now separated into two groups, the orthomyxoviruses and paramyxoviruses, due to the difference in various properties. Influenza viruses. Influenza virus has three serotype: type A, type B, and type C. Morphology. The morphology of influenza viruses is as follows: spherical particles. It is typically spherical, 80 to 220 nanometer in diameter, but pleomorphic and filamentous form or frequent helical symmetry. The nucleocapsid has a helical symmetry. RNA genome. It consists of negative sense single standard RNA genome which are segmented and exist in 8 pieces. The RNA genome is associated with the RNA dependent RNA polymerase. Influenza virus type C genome exists as 7 pieces in contrast to 8 pieces in influenza virus type A and that of influenza virus type B envelope. The nucleocapsid is enclosed by an inner protein layer called as a matrix or M protein and outer lipid layer peplomer attached to the lipid layer of the envelope and are two types of glycoprotein peplomeres or spikes, the heme agglutinin HA and the neuraminidase NA. The heme agglutinin spikes are triangular in cross section, while the neuraminidase spikes are mushroom shape, which are less numerous. Antigenic classification. Based on the difference of antigenic structure, influenza viruses are divided into 3 types ABC on the basis of antigenic variations of HA and NA antigen. These 3 types ABC can be divided into subtypes. 15 subtypes of heme agglutination H1, H15 and 9 neuraminidase N1 to N9 are known in birds, some of which have also been found in various combinations in humans. The human viruses shown 3 HA, H1, H2, H3 and 2 NA, N1, N2 type. The general non-human viruses do not infect man, but they place an important role in emergence of pandemic influenza by genetic reassortment with the human viruses. Antigenic structure. The influenza viruses have following antigens: ribonucleoprotein RNP. It is a type A, B or C specific. 3 types of influenza viruses can be differentiated on the basis of antigen matrix M protein. It is also type specific. The M protein is composed of 2 components, M1 and M2. The heme agglutinin HA. It is a strain specific and it is capable of great antigenic variations. It is a glycoprotein composed of 2 polypeptide HA1, HA2. These are present as a spike on each influenza virus particles. Neuraminidase. Like heme agglutinin, the neuraminidase is also strain specific. The enzyme neuraminidase, a glycoprotein, is present on the viral surfaces. It is present in the neuraminidase polymerase or spike. The enzyme neuraminidase acts on specific red cell receptors and destroys it. This specific receptor is a site for hemogglutination on the surface of the erythrocyte. Antigenic variations. A unique feature of influenza virus is the ability to undergo antigenic variation due to frequent changes in antigenicity of HA and NA. Antigenic drift. The antigenic drift refers to the minor antigenic changes in either the hemagglutinin or neuraminidase or both. This is a gradual sequence changes occurring regularly at frequent intervals. The antigenic drift results from mutation in the HA and NA genes. A new antigen, though different from the various antigen, are yet related to them, so that antiserum to the predecessor viral strains reacts with the mutant to certain extent. The periodic epidemics of influenza are associated with antigenic drift. Antigenic shift. More antigenic changes in HA, H2 and H3 or NA, N1 to N3 are called antigenic shift, resulting in emergency of new subtype unrelated antigenically to predecessor strain. It is an abrupt, drastic, discontinuous variation in antigenic structure. Such changes may involve hemagglutinin, neuraminidase or both. The changes involved in the antigenic shift are so extensive that they are unlikely to be due to the mutation. The changes probably results from gene reassortment recombination in doubly infected cells. because the segmented genome reassorted between a human and animal strain. The antibody to predecessor viruses cannot neutralize the new variant. Therefore, they can spread widely in the population, leading to a major epidemic and pandemic. Cultivation, egg inoculation. The influenza virus is cultivated in amniotic cavity of 11 to 13 days old chick embryos. After a few egg passage, the influenza virus type A and type B grow well in amniotic cavity. Also, the virus growth is detected by hemagglutination test performed with amniotic and amniotic fluid. Tissue culture. Influenza virus can also be isolated on a primary monkey kidney or human embryonic kidney. In animal inoculation, the influenza virus can can cause experimental infections in ferrets and mice by intranasal inoculations. Diseases. The influenza is an acute respiratory disease, and a clinical feature vary from mild coryza to fulminating pneumonia. The incubation period varies from 1 to 4 days. The uncomplicated disease usually resolves within 7 days. Laboratory diagnosis. The demonstration of virus antigen. The virus antigen in clinical specimen can be detected by immunofluorescence. It is a rapid method for diagnosis of influenza. The detection of a viral RNA by reverse transcriptase polymerase chain reaction is highly sensitive, but it is of a limited availability. Isolation virus. The influenza virus can be isolated during the first 2 to 3 days of illness. The throat quarantine or collected using the suitable buffer salt solution. The material is inoculated into amniotic cavity of 11 to 13 days chick embryo. The monolayer of a monkey kidney cell culture or human embryo kidney cells. After incubation of eggs at 35 degrees centigrade for 3 days, the amniotic cell and allantoic cell fluid are harvested separately. The fluid are tested for the hemoglobin. The isolates is identified and test type with the antisera to type ABC. Subtype identification is done by hemagglutination inhibition test. Incubated cell culture or incubated at 33 degrees centigrade, and the virus growth can be identified by testing the culture fluid for hemagglutination or by heme absorption. The rapid results can be obtained by detection of virus antigen in infected cell culture by immunofluorescence. Serology. There are routinely employed serological tests for diagnosis of influenza includes a complement fixation test, hemagglutination inhibition test. It is essential to demonstrate a four-fold or higher rise in titer of antibody between acute phase and convalescent phase sera. Immunity. An attack of influenza confers the protection effective for 1 to 2 years. When an individual has repeated infection with a different antigenic variant of influenza virus type A, he forms antibody not only against each infected strain but also against the strain that he first came into the contact with. The dominant antibody response will be shown against the strain that causes the earlier infections. The phenomenon here that has been called as a doctrine of original antigenic sin. Epidemiology. The influenza occurs sporadically as a epidemic or in pandemic forms. The influenza A virus causes a widespread epidemic and pandemic. The pandemic B strain causes a sporadic and sometimes epidemic, but C does not cause epidemic. The influenza type C usually causes inapparent infections. The epidemics and pandemics of influenza are associated with the antigenic shift. It is now believed that the pandemic strains originated from some animals or avian reservoirs, either spreading to man directly by mutations or as a result of recombination between the human and non-human strains. The most severe pandemic occurs in 1918 and 1919, during which over 20 million people persisted. Later on, different pandemics and epidemics occurs in various countries. A unique feature of influenza epidemiology was that once an antigenic variant emerges, it replaces completely the pre-existing strain, but this role has not been observed in recent years. Even after the reappearance of HSW1N1 strain in 1976 and the re-emergence of H1N1 strain in 1977, A3 Hong Kong strain continues to be prevalent. The reason for it is not known. In April 2009 was a case of influenza have appeared in Mexico and then in USA. It has been identified as a new H1N1 virus, and it can be transmitted from human to human. It had spread to many countries, including India. Prophylaxis. The vaccination is the primary means of prevention of influenza, but the major difficulty in immunoprophylaxis is the frequency changes in the antigenic structure of influenza virus. The vaccine cannot be made in bulk and stocked stockpiled as the appearance of new variant strains have made the old vaccine unless useless. The most important indication for immunoprophylaxis is when an pandemic is threatened by new viruses. Inactivated vaccines, the influenza viruses are grown in allantoic cavity of chick embryos and inactivated by formalin or beta biolactone. The vaccine can be further purified to contain only hemagglutinates and neuraminidase. This is called a subunit vaccine. The vaccine is administered parenterally in single dose. It gives protection for a short duration of 1 year. Live attenuated vaccine. The temperature sensitive TS mutant of influenza viruses are used. These can grow at a lower temperature, 32 to 34 degrees centigrade of the nasopharyngeal mucosa, but not in lungs, 37 degrees centigrade. Such a TS mutant are equivalent. They stimulates the production of local IgA antibody. Live vaccines is administered intranasally or by aerosol spray. Chemoprophylaxis, the remantadine or amantadine may be given orally to unimmunized people during a major epidemics of influenza virus. Treatment, amantadine and remantadine are useful in the treatment of influenza. They causes symptomatic improvement, but virus shedding and antibody response are not affected. Avian influenza, bird flu. The avian influenza viruses do not normally infect other than bird and pig. The virus may affect the human who have close contact with domestic birds such as chickens. H5N1, an avian flu virus strain, was first isolated in 1997 from human cases in Hong Kong. Since then, they report human diseases have appeared. Birds to birds transmission does not occur, but it has not been shown to be passed from human to human. The symptoms of avian influenza in human range from influenza-like symptoms to pneumonia and acute respiratory distress.